You'll notice in this lesson video we referred to Unit 8, Day 3. It should remain Unit 11, Day 2. These are the notes for Unit 11, Day 2. In today's lesson video, we're taking a look at quadrilaterals in the coordinate plane. Now remember, a quadrilateral is a four-sided polygon, and we're looking specifically at these main quadrilaterals: parallelograms, rectangles, rhombi, and squares. And so the first thing I want you to look at is these characteristics of these shapes. Now, parallelogram is our first classification. In any parallelogram, there are two sets of parallel sides, and opposite sides are also congruent. And so the way we kind of condense that, or those two, is by this criteria, that opposite sides are parallel and congruent. Okay, and that's our main big idea about parallelograms. Opposite sides are both parallel and congruent. Now, opposite angles are also congruent and diagonals bisect each other, but opposite sides being parallel and congruent is the main criteria we're looking at for parallelograms today. Then once we further classify parallelograms, parallelograms can be split into two other classifications: rectangles and rhombus. Okay, a rectangle is a parallelogram also, so all the characteristics of parallelograms still apply, and that's what you see here in the first one. Parallel sides, opposite sides are congruent, but this is the main criteria we're going to look at for rectangles, and that's that there are four right angles. Okay, and as we've been working with our coordinate geometry, we've been looking at lines in the coordinate plane. And you'll remember back to the previous lesson, 8.2, we looked at how to determine if lines were parallel, perpendicular, or neither. Sorry, that actually came from 8.1. In our first lesson, we looked at lines being parallel, perpendicular, or neither. Well, if I've got four right angles, then every pair of consecutive sides are perpendicular. So that's another way we can say that. Since there are four right angles, that means that consecutive sides are perpendicular. Okay, and that's our main idea for rectangles. Now, there's other properties. Diagonals would be congruent to each other, and diagonals bisect each other. But that one that I've put a box around, consecutive sides are perpendicular, is our main property of rectangles. Now, parallelograms can also be split into another category, and that's the category of a rhombus, okay? Or the plural of the word is rhombi. In a rhombus, there are still two sets of parallel congruent sides because it's a parallelogram, but all four sides are congruent. And that's our main idea here, is that all four sides are congruent. Four congruent sides. I'll use my abbreviation for congruent, the symbol. And that's our main one there. Now, opposite angles would still be congruent, and there's actually a typo here. Congruent diagonals is wrong. In a rhombus, diagonals aren't necessarily congruent. That was a characteristic of rectangles. But diagonals would bisect each other, and diagonals are actually perpendicular. But we are focusing on the four congruent sides here. That's our main idea for a rhombus. Now, if we have a parallelogram that has four right angles and four congruent sides, okay, four congruent sides makes it a rhombus, right? So if there are four congruent sides and four right angles, that makes it a square. Okay, a square is both a rhombus and a rectangle. Okay, so it has all those characteristics. And so if it has four right angles and four congruent sides, that makes it a square. Okay, because it's both a rectangle and a rhombus. So those are the big characteristics we're looking for. All right.
So before we move on to any of our examples, I do want us to look at how we can use these criteria to classify a quadrilateral as either a parallelogram, rhombus, rectangle, or square. And we can do that just by looking at the consecutive sides. So we can pick a set of consecutive sides and try and figure out if those consecutive sides are perpendicular or not, and then also look and see if those consecutive sides are congruent or not. So if we have consecutive sides that are perpendicular, that means we have right angles. Well, rectangles and squares have right angles. And if they are not perpendicular, then it would have to be a rhombus or a parallelogram. To figure out how to further categorize this, we need to look at their side lengths then. The side lengths could tell us if sides are congruent. So if consecutive sides are congruent and there are right angles, that would have to be a square, because it would mean if consecutive sides are perpendicular, there's a right angle. And if consecutive sides are also equal, then all four sides are equal. Well, that makes it a square. But if consecutive sides are perpendicular, giving us right angles, and we don't have congruent sides, then all we can say is that it is a rectangle. Okay? Now, if the sides are not perpendicular, but the consecutive sides are equal, that makes it a rhombus. And if sides are not perpendicular and they're not the same length, at the very least, we can say that it is a parallelogram. Now, to further go on and classify these things, to identify whether sides are perpendicular or not, that comes from our slope formula. And to determine if they are congruent or not, that's our distance formula. So those are the formulas we're going to be using along with this criteria in the rest of our examples. This next portion, you'll notice, is not exactly in your note packet, but it is a good reminder of some things before we move on to the rest of the guided notes. So for this part, just watch what's happening on the screen and pay attention to this piece, and I'll let you know when to get back to writing things down in the notes.
So what we're going to do now, we're going to apply these characteristics in the coordinate plane. And so we're going to recall some of the things we've been talking about in the previous lessons. Okay. In the previous lessons, we looked at three specific formulas. We looked at the distance formula, the midpoint formula, and we actually started the unit with our slope formula. So those three formulas are going to tell us some things about these characteristics. First of all, parallel sides would have to have the same slopes. Remember that if two lines have the same slopes, they're parallel. So our sides of these parallelograms that are parallel have to have the same slopes or equal slopes. So there's that slope formula we can use. Also, perpendicular sides, like in a rectangle, giving us those four right angles, have opposite reciprocal slopes. Now remember, opposite reciprocal means that one is positive, one is negative, and one is the flipped fraction of the other. And so here's an example of opposite reciprocal slopes. The opposite reciprocal of 4/5 would be negative 5/4, and vice versa. Okay, the opposite reciprocal of negative 5/4 is 4/5. Or here's another example. The opposite reciprocal of -3 would be positive 1/3. And those are opposite reciprocals. So those are examples of slopes that would give us perpendicular lines. And then finally, congruent sides would have to have the same length. Now remember that length in the coordinate plane comes from the distance formula. So there's that distance formula. Now we could use our midpoint formula, but we're not going to in this lesson. We could use it to show some different things, like that the diagonals bisect each other. That means they would share the same midpoint, but we're not going to go down that road. So as we work through these examples, you'll notice I don't give you a lot of graphs in this lesson. At the very end, there's a couple problems where we do the graphing. But for most of this, we're just working with the formulas. We're not actually doing the graphs. So the starting place for every one of these is to understand which points line up to give us the sides that we're using. Okay, which 2 points at a time are we going to use? So we do this by sketching each shape. I'm reading here in the middle of the page. We're going to sketch each shape by putting the letters in clockwise order. Now we could do counterclockwise, but let's just focus on one option here. We're going to go clockwise order around the figure. Okay, so if I called something quadrilateral A, B, C, D, that is going to look something like this. I'm going to pick one corner and start it with A, then go to B, then C, then D. You have to go around the figure like this. Okay, you have to go in order around and not zigzag. Okay, that creates the sides AB, BC, CD, and DA. And so for most of our examples today, that's what that's going to look like. So we're going to start with our first example here. We're told we have a quadrilateral ABCD and that it's a parallelogram. I don't have to draw this as a perfect parallelogram, but if it's going to help you understand it better, you can do that. We're going to go in this shape. Okay, I'm going to start at one corner and go around the figure ABCD. Okay, now if I graphed this, it may not necessarily look like that on my page, but the points would line up in that order. So the question is, what sides would have the same slope? Well, remember that in a parallelogram, opposite sides have the same slope. In that case, pairs of opposite sides would be like AB and DC. They would have the same slope. And then AD and BC would have the same slope. The next question, what sides would be congruent? Well, again, opposite sides are parallel and congruent in a parallelogram. So opposite sides would be congruent. That would mean like AB would equal DC. It would also mean AD would be the same as BC. So that's where we get some of these relationships. And so we're going to focus almost exclusively on slope and length today. So what we're going to do with this specific example on these parts here, we're going to answer the questions of the slope of AB and the length of AB first, okay? Remember that your slope formula is the difference of the y's over the difference of the x's. Y2 minus y1 over x2 minus x1. And these are the points we're using, okay? So y2 would be -2. And we're going to subtract y1, which would be 8. So -2 minus 8 over the difference of the x's. So x2 would actually be 0. We're going to subtract 4. And then we're going to simplify. -2 minus 8 is -10. And 0 minus 4 is -4. Negative over a negative becomes a positive slope, so those kind of just cancel out. 10 divided by 4 is just 5/2. So my slope of AB is 5/2. Do not write slope as a decimal. We always write slope as a simplified fraction. Now let's find the length of AB. Again, for length, we use the distance formula. I'll remind you of what that is. The distance formula is the square root of the difference of the x's, so x2 minus x1 squared, plus the difference of the y's, y2 minus y1 squared. So let's plug in what we have. Now we kind of have already done some of this work on our paper. We have the difference of the x's. The difference of the x's was 0 minus 4. And we have the difference of the y's. That was the -2 minus 8. So I can kind of shorten my work a little bit. 0 minus 4 is -4. But when I square -4, I actually get positive 16. Then -2 minus 8, that was this -10 there. And so when I square -10, I get positive 100. And then I add those together and I get 116. And then I do the square root of that. When I do the square root of 116 in my calculator, I get about 10.8. So the length of AB is 10.8. Then I ask these next two follow-up questions. I asked for the slope of CD and the length of CD, but I didn't give you the coordinates of those. But remember, this is a parallelogram. Since it's a parallelogram, opposite sides have the same slope and are congruent, or the same length. So CD is the opposite side of AB. So their lengths are equal, 10.8, and their slopes are the same, 5/2. Okay? Let's try another set of examples. Go ahead and turn the page.
Now this is where we pick back up with what you see in your note packet, so please make sure that you are following along and writing things down in the guided notes as you're watching this video.
We're going to kind of do the same thing here. We're told on this example, example 1, that ABCD is a quadrilateral. All I know then is that it has 4 sides. So I'm going to kind of just draw that as a basic rectangle, even though I don't know that's what it is yet. And we're told the coordinates of A and B. So again, I'm going to draw that out A, B, C, D, like that, so that I can identify which sides go together. And question 1, or question 1a, says, what is the slope of AB? So again, we're going to use our slope formula. Well, here's the coordinates of A, here's the coordinates of B. For slope, we take the difference of the y values on top, so that would be 2 minus 6, over the difference of the x values. 1 minus negative turns into plus positive 2. Okay, 2 minus 6, and then 1 minus negative 2 turns into 1 plus positive 2. 2 minus 6 is negative 4. 1 plus 2 is 3. So our slope of AB is just the fraction negative 4/3. Nothing to reduce there. So the next question, question B, says, what must be the slope of DC in order for ABCD to be a parallelogram? Since ABCD is a parallelogram, opposite sides are congruent and parallel, so the same slope of AB is the slope of DC, negative 4/3. Okay? On number 2, we're going to do kind of the same thing. On number 2, I'm going to actually have you pause the video here in a minute and try this one on your own. You're doing the same thing, but this time it says what is the length of AB, and it's 2 new ordered pairs. You got new coordinates here for A and B. So again, we're going to go from A to B to C to D in that order. And we want to know the length of AB. And then it asks what must be the length of BC to make this a square. So pause the video, try this. Remember, for length, you want to use the distance formula. If you need more time, keep the video paused. Otherwise, this is the answer you should get. The distance formula gives us that the length of AB should be 2.8. And so when it says what must be the length of BC in order for this to be a square, BC is a consecutive side with AB. That means they're in a row. They're not opposite sides. But this is supposed to be a square. And in a square, there must be 4 congruent sides. So that means that the lengths of all 4 should be 2.8.
So now as we continue on to our next set of examples, what we're going to do is we're going to look at a situation where we are given 4 coordinates of a quadrilateral. We're given the 4 coordinates of the vertices, and we're going to classify these as either a parallelogram, rhombus, rectangle, or square based on the criteria we looked at earlier. Now, you'll notice there's no graphs here because I don't want you to graph it and look at it to try and figure this out. We're going to use the distance formula and slope formula to figure this part out. So here's what we're going to do. We are only going to use consecutive sides. Okay, we're just going to pick 2 consecutive sides to do this problem. And for all of these problems, it's just easy enough to start with the first 2. So we're going to use the consecutive sides AB and BC. So the first thing I want you to do is to use your slope formula to calculate the slope of AB. Our slope would be our y value minus the other y value, so 3 minus 1, over our x value minus the other x value. So 3 minus negative 1 becomes plus positive 1. This would give us a slope of 2 over 4, which we can reduce to 1/2. Then I want you to find the slope of BC. So we're going to do that y value minus the first one. So the slope of BC starts with negative 6 minus 3 over, then our x value minus the other x value, 0 minus 3, which would give me negative 9 on top and negative 3 on the bottom. Those negatives are going to cancel, so we'll still have a positive slope here, and 9 over 3 reduces to just 3. Now I want you to notice that these 2 slopes are not opposite reciprocals of each other. They are not opposite, they're both positive, and they're not reciprocals. The reciprocal of 1/2 would be 2, not 3. Since these are not opposite and they're not reciprocal, we know that AB is not perpendicular to BC. Since they are not perpendicular, if I go back here to my previous chart, the only options then are rhombus and parallelogram. Okay, So to determine which one of these two it is, I'm going to go ahead and take a look at the length of AB and BC. So I'm going to go back to my AB segment, and I'm going to do my distance formula to find that length. So for your distance formula, the first parentheses is x2 minus x1. Well, we already did that here. So I can do 3 plus positive 1 then. And then the second set of parentheses would be y2 minus y1, which would be 3 minus 1. So to start simplifying this, the first parentheses, 3 plus 1 is 4. And the second parentheses, 3 minus 1 is 2. Then I have to square each of those. 4 squared is 16. 2 squared is 4. And then add them together. And that gives us the square root of 20. The square root of 20 is about 4.5. Well, now I'm going to do the same calculation for BC. I'm going to go back and do my distance formula for the coordinates of BC. When I do x2 minus x1, that is 0 minus 3. And y2 minus y1 is negative 6 minus 3. Well, 0 minus 3 is negative 3. And negative 6 minus 3 is negative 9. When I square the negatives, remember that you get positives. Negative 3 squared is positive 9. Negative 9 squared is positive 81. And if I add those together, I get 90. And the square root of 90 is about 9.5. Now, you should recognize then that AB does not equal BC. They are not congruent. Okay, they are not equal to each other. They're not the same length. So this cannot be a rhombus. It can only be a parallelogram. Okay? So as we move on to the next example, we're going to do the same thing. The first thing I want us to do is to go ahead and find the slopes of each of these consecutive sides. Again, we're going to pick the first two, AB, and then the next two, BC, for consecutive sides. So I want you to find the slope of AB and the slope of BC. In a moment, I'll give you a chance to pause the video and try that part on your own. And then I want you to come back and find the distances from A to B and the distance from BC, or the length of BC. Okay? And then you can further classify this. Okay, if you need more time, keep the video paused. Otherwise, this is what you should see. When you do the slope of AB, we do 1 minus negative 1 over 3 minus 0. We get 2/3. And then for BC, we do the slope of negative 2 minus 1 over 5 minus 3. We get negative 3/2, or negative 3 over 2. And what that shows me is that those are opposite reciprocal slopes. That means AB is perpendicular to BC. So I do have right angles, which means it can either be a square or a rectangle, because those have right angles. Since the consecutive sides are perpendicular, it can be a square or rectangle. Now I need to look at my lengths, my distance formula. So when I do the distance formula here for AB, that gives me 3 minus 0 squared plus 1 plus 1 squared. 3 minus 0 is 3. 3 squared is 9. 1 plus 1 is 2. 2 squared is 4. So I get the square root of 13. I'll bring up the calculator here real quick. If I do the square root of 13, I get about 3.6. When I do the distance for BC, I'll have 5 minus 3 squared plus negative 2 minus 1 squared. That also gives me the square root of 4 plus 9, which is 13 again. And the square root of 13 is still 3.6. That means AB does equal BC. So consecutive sides are perpendicular and they are congruent, which means this has to be a square.
All right, as we finish up, we've got one other kind of problem you're going to see, and these are actually a lot easier, a lot more simple. And these are the only ones where I actually give you graphs. So what we're going to do is we're going to use the points given, choose the final point to create a requested quadrilateral. They're going to request either a parallelogram, rectangle, or rhombus, or square. And you're going to justify this by showing slope on the graph. And all you need to do to show slope on a graph is to draw out rise over run. So I'm going to actually do example 2 with you because it's the one I want to do first, and then we'll go back and do number 1. The first thing you need to do is plot the 3 points they do give you on the graph. So A is at -2, 4. Remember that first coordinate is your x and y, your left and right. So -2, 4 puts A right there. B is at 2, 2. So you notice I plotted my point, but I also labeled it. We need to do that on all 3. B is at 2, 2, right there. C is at -1, -4, right there. Now, I need to find the coordinates for D. And I'm going to do that by graphing it. So remember, we go around the figure, A, B, C, then D, like that. That means I go from A to B, then B to C. So D has to be somewhere over here. And I'm not just going to guess at that. I'm going to use my criterias for rectangles, or more importantly, parallelograms. In a parallelogram, opposite sides are congruent and parallel. That means they have the same slope. So all I have to do is repeat the slope triangle, rise over run, for one side on the opposite side. So let's say I wanted to go from B back up to A. I would go up 2, to the right 4, or to the left 4. Up 2, to the left 4. So I can repeat that pattern. I can even use a little demonstration here to show you. I can repeat that pattern from C up 2, to the left 4, and that puts my point for D right there. So D has an x coordinate of -5 and a y coordinate of -2. And if I connect D to the other sides, you see that it is a rectangle. All right, let's try that again on number 1. We'll finish out our last example here, and we'll try that. We're going to plot the original points first. A is at -2, 3. There's A. B is at 4, 3. A little bit different points this time. There's B. And C is at -1, -2. There. This time, this is supposed to be a parallelogram, so don't expect to see 4 right angles here. So I'm going to connect sides A, B, and then B, C. That means D is going to also have to be somewhere over here. I don't know exactly where yet, but I can use opposite sides are congruent and parallel. Well, this time it's a little bit easier because one of my sides is already a horizontal line. I'm going to use the pattern from B back to A. That would just move backwards 1, 2, 3, 4, 5, 6 spaces, -6. So I'm going to use that pattern from C. I'm going to go from C backwards 1, 2, 3, 4, 5, 6, and my circle was a little bit off. I'll just move that. Okay, that puts my coordinates for D right there, which has an x coordinate, if you count, that's -7, and a y coordinate of -2. So that's where D would be, and that turns that into a parallelogram. So that's how you find a missing coordinate or missing point or missing vertex of a quadrilateral. Well, that wraps up our lesson for 8.3. If you have any questions, make sure you message me. Otherwise, you should be ready to start the assignment.